Welcome all of you to this video. So far, we have studied about the total surface area and the volume of new solids formed by the association and dissociation of basic solids. Moving forward with this concept, today we will learn about frustum of a solid cone. Dear children, let's see a new shape of this solid family, which looks like a cone but is not a cone by shape. It's a part of cone. We call it frustum of a cone. If cone is cut horizontally, it gives one frustum of a cone. Today, we will know this. When pointed area of cone is removed, the rest is called frustum of cone. Frustum is a Latin word which means sliced piece. Just as you are familiar with all the solid shapes in your daily life, in the same way, you have seen the frustum of cone around you, such as this glass of water, bucket, bowl, cup, flower pot, table lamp, shape formed by light emanating from table lamp, etc. Let us now observe it. To understand the frustum of a cone, let's take a cone whose height is capital H, capital L is the slant height, and capital R is the radius. If we cut this cone parallel to its base, like this, we get two pieces of the cone. So can you tell what are these two pieces? Absolutely correct. The top piece is a cone and the bottom piece is the frustum of the given cone, which we are going to discuss today. You can see that the frustum has two circular ends. Its lower end is called the base of the shape. Can you tell the radius of this base? Absolutely correct, because it is the lower part of this cone. Therefore, its radius will be the same as the radius of the cone, which is capital R. If we represent the subtracted radius of the upper end as R, the height of the frustum as small h, the slant height as small l, then we can find out slant height, total surface area, curved surface area, and volume of the frustum with the help of their formulas. Can the radius of both ends of the frustum of a cone be equal? Give it a thought. Today we learned about the meaning of frustum of a cone. In the next video, we will solve the problems faced in our daily life based on the frustum of a cone. Welcome all of you to this video. So far, we have learned what is the meaning of frustum, what is meant by frustum of a cone. Today, we will solve the problems faced in our daily lives based on frustum of a cone. Rita wants to make a paper cap in the shape of a frustum of a cone, the height of which is 14 cm and the radii of the circular ends are 6 cm and 8 cm. If the cap is open from the side with a bigger circle, then tell Rita would be needing paper of how many square centimeters to make the cap. Pause the video to try yourself and then match your answer. Can you tell how we can find the size of the paper? Absolutely correct. For this, we have to find the surface area of the cap. Because cap is open from the bottom and closed at the top, so we will not find the total surface area. Rather, we will add the area of the closed end to the curved surface area. The area of the open end will be subtracted from the entire surface area. We will solve this question in the first way, and the second way will be left for you to try. Now we mark the given measurements as follows. In the previous video, we learned that the curved surface area of the frustum of the cone can be derived from this formula. Since the closed end of the cap is circular, here we will use the formula for the area of the circle. From the formula, you can see that to find the curved surface area of the cap, we need its slant height, which is not given in the question. Now, how can you find the slant height? Well done. We can find the value of the slant height from this formula. Replacing all values, on solving, we get the value of L, that is, slant height 10√2 centimeters. Now replace all values in these formulas. On further solving, we get 733.48. So Rita would need 733.48 square centimeters of paper to make a hat. Let's see another example. A bucket which is 15 centimeter deep and the radius of the upper and the lower portion of which is 20 centimeters and 10 centimeters respectively, then how much water will it hold? From the question, we know that the radius of the top of the bucket is 20 centimeters and that of the bottom is 10 centimeters and with the depth 15 centimeters. Also in this question, the value of pi is given as 3.14. So, can you tell how much water can be filled in this bucket? For this, we have to determine the capacity of the bucket, for which the formula of volume of frustum of the cone will be used. Solving by substituting all the values, the capacity of the bucket is found as 10,990 cubic centimeters. Also, we know that 1000 cubic centimeter is 1 liter. Therefore, 10.99 liter or about 11 liters of water can be filled in the bucket. Today we learned to solve the problems faced in daily life based on the frustum of the cone.